Okay, hello. Looks like it's 6:30 already, so I'll be starting. My name is Mole Zong. I'm a high school student at Lisa Niguel High School, and I'm gonna be majoring in computer science in the future. So I'm teaching today's class for ACSL. So last time you guys learned about number systems, binary, hexadecimal, stuff like that, and how to convert between these number systems. And today's lesson, we'll be learning about prefix, infix, and postfix notation and how to convert between them. So infix to prefix, infix to postfix, and prefix to infix, and postfix to infix. And here are some resources you can use if you want to learn more or get more into detail. These are just the ACSL website links. And this one is specifically for infix, prefix, and postfix notation. So first order of operations, it goes from parentheses and then exponentiation, multiplication, division, addition and subtraction. And if you have multiple of the same level, then you just do it from left to right. So just to warm up, can I have everybody evaluate this expression? And if you have an answer, feel free to send it in the chat. Yeah, so we have two parentheses in here, this one and this one. And let's just start with this one on the left. And first we'll evaluate each expression inside each parentheses. So this one's 3 plus 5, that's 8. And then we have 4 minus 2, that's 2. And then we have 2 minus 8, which is negative 6. And then we have multiplication and a subtraction here. And multiplication comes first. So we have 8 times 2 is 16. And then minus negative 6 is 22. So this whole parenthesis here is 22. And then we have divided by 1 plus 1. Well, 1 plus 1 is 2. So 22 divided by 2 is 11. Unless I did something wrong. Did I? Oh, I'm sorry, everyone. Oh, wow. I really messed up. Okay. So, oops. That's not a good way to start. Yeah, okay, let's restart. So we have these parentheses and then these parentheses. Okay, so multiplication and then division. Yeah, my bad, guys. Here we go. 3 plus 5, that's 8. 4 minus 2 is 2. So, and then we multiply these two together, that's 16. 2 minus 8 is negative 6. Divided by 1 plus 1 is 2. So then this one is 3, negative 3. So 16 minus negative 3 just becomes 19. And it looks like, yeah, sorry, everybody. I messed up a little bit. 19. Yeah, so if you subtract the negative number if you subtract the negative numbers, same thing as addition. So 16 minus negative 3 is 19. Okay, now let's go into prefix notation, the main thing of our meeting. So in prefix notation, the operator is placed before the operands. And sometimes we need this, like it's used in a lot of programming languages like Lisp. And it's easier to parse for a machine because if you have prefix notation, you don't need to read the whole thing to figure out which operation to do first. You can just read it from left to right once and then evaluate it. So That way you can save a lot of time instead of having to reread the expression over and over again to find out the next operation. So here's some examples. So if you have a plus b, then the plus just goes before the a and the b, so it's just plus ab, and a times b plus c divided by d. This plus between the b and c just go before, and then the multiplication goes before the a and the b plus c, and division goes at the very front because it's the last operation that you do. And as you can see, the operators are written before the operands, and it's very easy. There's no parentheses, and you don't need to worry about operator order. You just do it in the order that you see it. And it's also easy to implement using stack, which we'll get into later. And then the same goes for postfix notation, where the operator is placed after the operands. And sometimes we also need this. This is used in code generation in the compiler, and it's easier to parse for a machine for the same reasons. You don't need to reread the expression over and over again to figure out the next operation. So as an example, you can see a plus b turns into ab plus, right? And infix notation, a times b plus c divided by d turns into abc plus times d divided by. And the operators are written after the operands, and there's no parentheses, no operator order. And you can also implement this using stack. And so what is stack? Well, stack is a type of data structure in which the last element that you put in is the first element that you can take out. And you can kind of think of it like a Pringles can or like a stack of pancakes over here. And so if we have a Pringles can, you can put in Pringles in any order that you want, like this. But then when you reach your hand in, the only Pringle you can take out is the top one. You can't take out the ones underneath it unless you've taken out the ones above it. Or you can't take out the ones underneath unless you've taken out the ones above it. So the three operations that you can do on a stack is push, which is putting in the element or the Pringle, pop, which removes the top Pringle, and then peek, which just looks at the top element without removing it from the stack. So next we'll cover how to convert infix to prefix and postfix notation. To do this, you just write down the operands in the same order that they appear in the infix expression. And then you look through the expression, you'll find out the next operation that you're supposed to do, and then put it before the operands that's operating on. So if we have an example here, a plus b. So our two operands are a and b. We just write them down in the order that they appear in. And then in the original expression, we have a plus here, and it's adding a and b. So we just put it in front of a and b like this. So the final expression is plus ab. And this example, it's a little bit more complicated, but we just follow the same steps. We have a, b, c, and d. That's the order they appear in. And then because of this parentheses, we have the addition going first. So we take this plus, and it's adding b and c. So we just put it in front of the b and c. And then next we have multiplication. So the multiplication is multiplying a, and then this whole b plus c over here. So we just take this multiplication and put it in front of the a. And then finally we have this division. And this division is dividing this whole term over here by d. So we can just put this division at the very beginning. Right? So next, let's do an example. So yeah, just try to turn this infix notation into prefix notation. And then if you have an answer, please just send it in chat. I'll give you guys a little bit of time to finish this. Yeah, while everyone's working on, if you have questions, you can just send in the chat and I'll try to explain it more. Oh, so the E just means it's just an exponent. Yeah, so you take this and then you multiply it by itself E times. Yeah. Yeah, no problem. Okay, it looks like a lot of people have sent in their answers, so I'll go over it now. Um, oh, so here's the steps. I'll try to explain. So first, let's just write it out all in one line, so we can have the operands and operators. And if you, by the way, this arrow, it just means an exponentation or exponentiation. So so this and this is the same thing. Yeah, so first, once again, we have the parentheses. So we evaluate the inside first. And then on the inside, we have A times B. So we just take this times and we put it in front of the A and the B, like so. So it's times AB. And then we have C divided by D. So we take this operand and we put it in front of the C and the D. And then the last operation inside the parentheses is the subtraction. So, and it's subtracting A times B and C times D. So we can just put this in the front. And then finally, we have the exponent. And then this is just raising this whole thing to the power of E. So we can put this in the very front. And once again, if you have questions, please send them in the chat right now. Okay, we'll move on. Okay, now converting infix to postfix notation to, oh, sorry, it looks like we have a question. The division. No, we moved the division in this expression. So in this, it was dividing C and D. And then here we just moved it in front of the C and the D. So yeah, because well, in prefix notation, you have the operation before the operands. So, and so let's just look at this term, right? C divided by D. The two operands are C and D, and then your operation is divided by. Yeah, so you just have, okay, yeah. Divided by divide CD. Okay. Infix to postfix notation. Um, so to do this, you just same thing as before. You write down the operands in the same order that they appear in the infix expression. And then you look at the first operation you're supposed to do, and then you put it in front of the two operands or behind, or sorry, what I mean is after the two operands that it's operating on, right? So here we have some examples. A plus B. So you write out A and B like before, and then take this plus, but instead of putting it behind, in front of the A and B, you put it behind, so it becomes AB plus. And the same thing goes for A times B plus C divided by D. It's write out A, B, C, and D. And then the first operation is this plus between B and C. And you take this and then you put it after the B and C like so. And then next you have this multiplication between A and B plus C. And you just slap it on after ABC plus like so. And then finally this division sign, it's dividing A times B plus C and then D. So you just put it at the very end over here. So we have the same expression as earlier, but now I want you to convert it to uh, postfix notation. And yeah, like before, send into chat if you're finished. Oh, Donald, sorry. Um, so do you mean why does it work? Oh, sorry, give me a second. Sorry, my sister was talking. What do you mean? Do you mean why are we learning how to do prefix, infix, postfix? It's gonna be on the ACSL competition, so yeah. So we're just learning these topics so you're not confused during the competition. Um, Johan, this is the same expression, but just try to evaluate in postfix instead. Yeah, okay. I'll explain the how to convert infix to postfix one more time for people who came late. You just yeah, you write down the operands or the numbers slash variables that you are operating on in the order that they appear, and then you look at the first operation that you're supposed to do, and then you just place it after the operands instead of in between them. So I'll do a smaller example over here. So if you have A plus B in parentheses uh, times C, right? Then this would, because of the parentheses, you would look at the inside first, and then this plus is the first operation you would do. So you just put this, so first let's write out ABC, right? And then this plus is the first thing you do. So you write it after the A and B. And then you have this multiplication next, and then it's between the A plus B and the C. So we can just write it after everything like this. Yeah. So Donald, do you have any more questions? Okay. Yeah, if you're confused, you can just ask questions in the chat. Okay, so let's go over this. Yeah, like before, we're writing it all out in one line. And then let's write out, so we write out all the operands in the order that they appear, A, B, C, D, E, and we look inside the parentheses, and this multiplication comes first because uh, multiplication before subtraction, and to the left of the division. So we have AB and then times. So, and then we have the division next between C and D. And we just put this after the C and D that it's dividing. So CD division. And then finally, we have this inside the parentheses. I mean, we have the subtraction, and we just put the, and it's acting on the A times B and C divided by D. And then we just put this after everything. So it becomes AB times CD divided by, and then minus. And then this exponentiation comes last. It's raising everything here to the power of E. So we can just put this at the end. Okay, moving on. So, sorry, people in the chat, please try to just keep it to questions only so that I won't miss a question if somebody does send one, and I can help people that are still confused. Thank you. Okay, next, converting back into infix after you get it in prefix and postfix notation. So to do this, we need to use a stack. And starting with prefix, you read the prefix and expression from right to left. So in reverse order. And if the symbol is operand, then you put it in a stack. And if it's an operator, then you pop the two operands from the stack, right? And then you take these two operands and then combine them together using the operator. And then you put it back onto the stack. And just repeat this until everything becomes one term in the stack. So I'll show this really quick. So using this first expression, so we have times plus AB minus CD. So reading it backwards, we have D first. So let's make a stack here, D. And the next we have a C. And then we have a minus. So since this is an operation instead of an operand, we have to take out these two elements and then combine them together using the operation. So then we have C minus D, right? And then, no, we don't need to use the operands in reverse order because we're reading backwards. We're just reading it backwards so we get the numbers that we're working with first, and then we put the operation. No, so okay, so we're evaluating it so that the value will be the same. So if we, yeah, yeah, sorry, your name is invisible. Like, I don't know what your name is. What this person said, we're not changing what the value is. We're just reading it backwards so that it's easier for us to evaluate it. Great, so we combine the C and the D and the minus into C minus D. And then we have B, so we put that in the stack. And then A, which is an operand, so we put it in the stack. And we have a plus, so we take out the A and the B, take it out, and we have a plus B. And then finally, we have this multiplication sign. So we just take out so these are the only two remaining elements, and we just take these out, and we just combine them all into A plus B with parentheses times C minus D. Okay, so let me go through some questions. Yeah. If anyone has questions, just send them. Why does the minus go between the C and the D? Okay, so this expression is written prefix notation. So that means the operation goes before the operands. And then, so this is our operation. Yeah, and then we have these two as our operands. So that means that we have our operands C and D, and then we just, or C and D, why did I write B? And then the operation goes between them like this in normal or infix notation. Sorry, is your name Cece? Can you please clarify your question? Is it a bracket C minus D or Tyler? Okay. If nobody else has questions, we'll be moving on. And also a variety. So a lot of languages use prefix notation. I mean, some like the majority I think use infix, but like there are some that use prefix because it's easier to parse. And Tyler, right now we're working on prefix, infix, and postfix notation, which is will be on the ACSL like test. So if you missed a lot of it, you can later go back to these slides and review. So next we have this. Yeah, so next we have this expression. So can people just, so I want you guys to try and turn this into infix notation and then send your answer into the chat. Oh yeah, make sure you're using parentheses so that the order of operations doesn't get changed. Yeah, we're doing the second one. I'll give it like 30 more seconds and then I'll go over this one. Okay, sorry. And then now, looks like everybody tried it from the self. Now let's do the second expression by yourselves. So this one's a little bit more complicated, but just follow the same steps, putting the operands in a stack and then going through it backwards. And then once you're done, type in the chat. Okay, I think a lot of people answered already, so let's go over this one. All right, so let's set up our Pringles can or stack. We start with L, put it goes in the stack, and then we go to K, go in this, and it goes in the stack. And then we have A, which is also an operand, so it goes in the stack again. And then we get our first operation, which is division. And then so we just take out our top two operands from the stack, which is A and K, right? And then we just divide them. So A divided by K. Okay, and then let's keep going. Then we have a subtraction here. So we take out our top two elements again, A divided by K and L. So this becomes, well, looks like I'll have to make this wider. A divided by K minus L. And let's just put this in parentheses. Okay, and then we have C. C goes on top of the stack. And then we have B, which goes on top of the stack. Just erase this. And we get divided by. So we take these top two, B and C, and turn it into B divided by C. And then let's keep going. So, and then the next one is A. And the operation is subtracted. So we just take the top two, A and then B divided by C. And then this becomes combined into A minus B divided by C. Right? And then finally, our last operation is multiplication. So we just take both of these. And this becomes A minus B divided by C. And let's put in parentheses so it's not confusing. Multiplied by A divided by K minus L. Yeah, so for prefix, you have to work backwards just so that you get the operands first before you put the operators. Yeah, so if when you're converting, you try to go through, yeah. Sorry, Jaden. We're currently learning this for the ACSL competition. Yeah. So we'll go over a postfix notation after a prefix, but let's try one more exercise. And this time, just give me a value instead of an expression. So just the final
Are these
number.
double-digit or single-digit numbers?
Just assume these are single digit numbers. Hi, Donald. Yeah, we're working on the new one right now. Okay, I'll wait for two more answers and then explain this one. Yes, CC, we're moving backwards through the expression. And we're working on the last one right now. Okay, so let's just go explain this really quick. So once again, have your stack. We have 5 and then 7. And then our next next element is a minus. So we do 7 minus 5. We take these out of the stack. And then 7 minus 5 is 2. So we put 2 back in the stack. And then we have another 2 goes in the stack, 8. And then a division. This is an operation. So again, we take out the top 2 and we evaluate it. So 8 divided by 2 is 4, right? And then 4, pop it in the stack, 3, and then we have multiplies. And so we take out 3 and 4, and then this becomes 12, right? And we have a plus sign. So we take out 12 and 4, and 12 plus 4 is 16. And then last, we have a exponentiation. And then, so this becomes 16 to the power 2, which is, so we take out the 16 2, and that becomes 256. So it looks like everybody got it right. Okay, so next let's move on to converting from postfix to infix. So this is the same idea as prefix infix. We're using a stack, except this time we read the expression from left to right. And this is because in postfix, the operands come first. So if the symbol is an operand, again, we put it on the stack. And if the symbol is an operator, then we take the top 2 operands and then we combine them. We combine them using the operation. And then we put that combined term back into the stack. And then we repeat this until everything becomes one term, or we reach basically until we reach the end of the prefix expression. Yeah, so I'll, I think you guys got the idea from the last one. So try to work on this one by yourselves this time, converting postfix to infix. So remember, you go from left to right and just follow the same steps. The arrow means an exponent. Oh, sorry, I forgot to clarify. Um, yeah, this is 25. Yeah, just this should be one number, and this is 10. Yeah, so there isn't a space between these, so this should be just one number. So that might be why your answer is a little bit different. The arrow means an exponent. So if you see an arrow, It just means you raise the first number to the power of the second number. Yeah. Okay. Uh, so let's go through this one. So this time, because it's postfix, we move from left to right. So we put 7 in our stack first, and then a 2, and we get an exponent. So we raise 7 to the power of 2. So let's take this out. 7 to the power of 2 is 49. That's at the bottom of our stack now. And then we have a 25, and then a 10, and then a 5. And then we have a division symbol. So we take out the 10 and the 5, and we do 10 divided by 5. That is 2, right? Okay, and then we get a plus, and then we take out the 2 and the 25. So 25 plus 2 is 27. We get a multiplication. So 27 times 49. Sorry, I'll have to take out my calculator for this. 27 times 49 is equal to 1,323, right? And then finally, we get a 13 and a minus. So we take out the 13 and the 1,323, and we get 1,323 minus 13, which is 1,310. That's our final answer. Yeah, okay, so we have some questions. 42 comes from the 7 and the 2. It's this, and then we have an exponent after it. So we raise 7 to the power of 2, which is 7 squared. So 7 times 7 is 49. And it might be a little bit hard to see for you guys, but yeah, the reason this is one number and this is one number, but then this like a number by itself is because there's no space between the 2 and the 5. Okay, if nobody has any more questions for this one, try to do this one by yourself, postfix to infix. Once again, remember to move from left to right using the stack. And this time, all the numbers are just single digit. Yeah, we're solving the last one. So just find out the value. Okay, I think a lot of people have answered. Or I'll give you guys a few more minutes or seconds. Okay, uh, so let's go over this. So reading from left to right, we have 3 and then 4, and then multiplication. So we take out the 3 and the 4, This becomes 12. There we go. And we get an 8 and a 2. And then a division. So we take out the 8 and the 2. And this becomes 8 divided by 2. So that's 4. And then we get a plus. So we take out the 4 and the 12. This becomes 16. And we get a 7, 5, subtraction. So we take out the 7 and the 5. And 7 minus 5 is 2. So we put 2 back in the stack. And finally, an exponent. And we saw before 16 to the power 2 is 256. Okay. So that's that. And then for this last one, we have some practice problems from like actual ACSL competitions. So if you can do this easily, you should be, or if you can just do this, you should be pretty set for the competition. Yeah, just working on the first one right now. If you have an answer, send it in the chat. Oh, and tell us, yeah, just don't send answers for number 2 right now, just number 1. And we'll go over number 1 and then move on to number 2. Yeah, remember postfix is having the operation after the operands. Yeah, you can convert it to infix and then solve. Sorry, I think I saw your question earlier, but I forgot to answer it. Okay, I think everybody's tried it, or yeah. So let's go over it. So postfix expression, that means we're going from left to right. So let's make a stack over here. Somebody asked if you can convert it to infix first and then solve it. So I think we'll do that this time. Just as an example. So 6 and then 2, and then we exponent. So we take out 6 and 2 and combine them using that exponent. So we have 6 to the power of 2. Okay, and then we have another 6 and a minus. So this becomes, so take out the 6 and 6 squared to become 6 squared minus 6. And then we have a 5 on top and a division. So we take out the 5 and the 6 squared minus 6, and we get 5. Oh, sorry. 6 squared minus 6 divided by 5. And then we get an 8, a 6, and a 2, and a plus symbol. So this becomes 6 plus 2. And then divided. So we take the 6 plus 2 and 8. And this becomes 8 divided by 6 plus 2. Right? And then we have a minus. So we do 8 divided by 6, or sorry, 6 squared minus 6 over 5. I'll try this over here. And minus 8 over 6 plus 2. And then, okay, so it becomes the same in the end, but you can see it's like taking a lot of time, which is, so you can convert it to infix notation first. Yeah, but like it'll be really slow. So I probably recommend you to just simplify the terms as you go. So let's finish this out. We have another 5, right? And then you have it divided. So then this becomes all of this divided by 5. And then let's see, 6 squared minus 6 is 30. Um, Divided by 5 is 6. And then you have minus 8 over 6 plus 2. So it's 8 over 8 is equal to 1. And so you have 6 minus 1 is equal to 5. All over 5 becomes 1 in the end. So it's the same answer in the end, but it's like really, really slow if you have to take out the whole expression and then put it back in again. Yeah, so when you're doing it, just like simplify the numbers as you go. So you don't have to rewrite everything. And then now let's move on to the second question. And once again, if you have an answer, just send it into the chat. Oh, sorry. Yeah. Oops. Convert. Oh, we'll find the answer too, just for practice. Well, on the ACSL, yeah, just do both so you guys get some practice. But this time when you're doing it, you have to keep the original expression or keep the expressions without simplifying. Yeah, guys, if the question asks for convert, just convert it first, and then from the converted like expression, you can simplify it. We're not looking, guys, right now we're not looking for a value, just the expression. So this one might take a little bit longer. Okay, everybody, I think there's a little bit of confusion. Remember that all these numbers are single digits, so this isn't 93. This is just 9 and then 3. And we're working with prefix now, not postfix. So you might need to redo a little bit. Okay, so let's start going over this question. I think a lot of people, everyone's had a try at it at least. So it's a little bit complicated going from prefix to into postfix, but let's just go to infix first, and then from there we'll go to postfix. So this time, since we're doing prefix, we start from the right side and we go to the left. So we have 3 and then a 9, and then this becomes 9 divided by 3. And remember, we're keeping it as a expression because we're converting it, not evaluating it. So 9 divided by 3, and then we have a 4 and a 1, and then this becomes an exponent, which is 1 to the power of 4. Here we go. And that sounds a little bit silly, but you have to keep it for the expression. So 1 to the power of 4, and then we have a 5, a 4, another 5, and then a minus. So these top two become 5 minus 4. And then we get a plus, so that becomes 5, 5 minus 4 plus 5. Right? And then a times, so we take out all this. Sorry. 5 minus 4 plus 5 times 1 to the power of 4. So 5 minus 4 plus 5, and we'll have to use parentheses this time because order operations, times 1 to the power of 4. And the final one is division. So we can just take out these two elements and divide them. So I'll just put a line here for division. And so let me see. Is this more or less what people? Yeah, okay, so this is infix notation now. And then now we need to go to postfix notation. So let's write this out in one line. Up here, 5 minus 4 plus 5, parentheses, multiplied by 1 to the power of 4. I'll just use the arrow so it's all in one line. And then 9 divided by 3, or divided by 9 or divided by 3. Okay, so once again, we put all the numbers or the operands in the order they appear first. So 5, 4, 5, 1, 4, and then 9 and 3. And just working from left to right, let's do the parentheses first. So let's work on this one. 5 minus 4 plus 5. Starting with 5 minus 4, we'll take the minus and put it in front like this. And then we have a plus. Oh, sorry. Postfix notation. Right. Okay. So 5 minus 4, we put the minus here. And then we have a plus 5. So we add the 5 in front after the 5. And then in the back here, we have 9 divided by 3. So then we take the division and put it after 9 and 3. And then we have an exponent, 1 to the power of 4. So we take the exponent, put it after the 1 and 4, like so. Okay. And then we also have we have the multiplication and division over here left, right? So we're dividing or multiplying 5 minus 4 plus 5 by 1 to the power of 4. So let me change color so it's easier to see. So this is one term, and then this is our other term. So we'll just put the multiplication after both of these. And then we have a division, and this is dividing all of this by this, so we can just put the division at the end. And let me see. Yeah, sorry, we're going a little bit over the time, but yeah. So if anyone has any questions, you can ask right now. Daniel, yeah, because the plus and minus are commutative, um, you can change the order that you put them in. But you have to make sure that the operands are like being the operations are acting on the same operands. Yeah, so prefix means that the operations go before the operands, and then the postfix means the operations go after the operands. Okay, if nobody else has any questions, that'll be the end of class. So thank you guys for coming, and I'll see you guys next time.
Bye. Thank you.
Bye,
Thank
guys.
you.
Bye. Thank you. Bye.
Thank you.
Suckers.
Wow. Okay.